This is the electricity test or practice test number 4. A potential difference of 16 volts is found to produce a current of 4.5 milliamps in a wire that is 1.2 meters long and has a uniform radius of 2.3 millimeters. We want to find the resistance of the wire, and then we want to find the resistivity of the wire. Okay, so what do I have? I've got a potential difference of 16 volts. I've got a current of 4.5 milliamps. Okay, that's the same as 4.5 times 10 to the negative third amps. I've got a radius of 2.33 millimeters. That's the same as 2.3 times 10 to the negative third meters. Okay, and we've got a length of 1.2 meters. Okay, length 1.2 meters. Okie dokie. Let's see, full screen. Alrighty. Well, thank you, VG Antivirus Free. I'm glad you updated successfully. Okay, so first thing, I want to find resistance. Well, I know that resistance is the same as delta V over I, Ohm's law. So that's all I have to do. Delta V is 16 volts. I must use standard units, SI units. Okay, so resistance is a very large number, actually. 16 divided by 4.5. Ah, yes. Okay. So I got 3,555.55555. So it just goes on forever. I only had 2 sig figs here, so I'm personally going to round to 2 sig figs, which would be 3,600 ohms. Remember, as long as you don't go crazy with the sig figs, we're okay with them. Okay. Part B, we want the resistivity. Resistivity is that number that we use. It had to do with what the material was made out of, and it shows up in the equation for resistance, which is also on your orange sheet. So resistance was resistivity times the length of the resistor divided by the cross-sectional area. Now in this case, the cross-sectional area is going to be the cross-section of a circle, which is pi r squared. Okay, so if I rearrange this for resistivity, I get resistance times pi r squared divided by length. Okay, and that's all I have to do. I'm going to go ahead and use the resistance from the last answer. That's going to introduce a little bit of rounding error, but that's okay, because that's how you do it on the AP test. You use this answer here. So 3,600 ohms times pi times 2.3 times 10 to the third meter, or negative third meters, squared. Don't forget to square it. Don't forget to square it. Over 1.2 meters. Okay. That is going to give me 0.050. And if the units, they work out to be one of these m's cancels this m. So we're left with an m on top and an ohm. So it's ohm meters are the units. Oops. Blah. Wow, that was a terrible... I don't know what happened to that box. Anyway, that's the answer anyways.